right, well, we're going to see here in this new chapter. That's module 8. Oh, we got 9. Come on. There we go.
Are we going to be doing the experiment?
Not today. Hopefully, we'll come back to Christmas break. All right.
You're not like trendy enough to just Huh?
Okay. We always avoid you, Jack, Karina.
Story about that?
No.
I just watched, I don't know if you guys have seen it, but Chris was able to show me the video about the guy who had a package stolen from his house. So he created this nice looking package. It actually has 4 cameras inside.
Oh, yeah.
And if you open it up, it spins glitter everywhere.
Yeah.
And then activates a fart spray.
I've seen that out.
And then he came out with version 2 where the spray was even stronger odor. And there's 2 bottles activating at the same time. And then it does it again. And it does it again. And then there's a countdown. 10, 9, 8. And then there's police chatter.
No.
Saying,
Oh, that's great.
you know, we think we found the package. It's in motion. Let's zero in on the address.
Well, you won't steal again.
And so then the people put the cover back on the box, and they try to take it outside and throw it in a dumpster or something. You know, it's hilarious. But this guy, where he gets all his money. Well, I guess he was making money from YouTube. He's still making videos on YouTube.
Oh,
Can you also put like a tracker in it so you can find it after?
Yeah. Yep. So the video is all being uploaded, so he has access to it.
Is he doing it to like bait people to steal the package, or do people just steal the package?
They just steal it. It's on his front porch. He puts it on his front porch, and people walk by and take it.
Yeah, like if Amazon delivers a package, then
Yeah.
just take it.
It's not yours!
We used to have that problem in our neighborhood. There was one kid.
Really?
There was one kid who kept doing it, so we had to start signing packages. Then he moved. He could keep doing it.
All right.
That never
This chapter 8
No,
is
too much effort.
the hardest chapter so far.
Oh boy, so far.
There'll be a couple more challenging ones, but this is the hardest one so far. And the hardest thing is pronouncing the name. Okay, so you see it there on page 276.
Stoichiometry.
How do you think you say that big word?
Stoichiometry.
You're actually supposed to get an oi in there. Stoichiometry.
Is that like bleach?
Say it again.
Stoichiometry.
Stoichiometry. And like we said at the end of the previous chapter, the tic-tac-toe and away we go is the best method for doing all of this. So let me walk you through the practice problem, and then I'll have you come up to the board and do some. We are recording this for training purposes for our 2 homeschoolers who are not with us. All right. So, do you remember in the, oops, this is the wrong one. Like this one, I'm probably going to have to get some more markers in here because these are dying to death. All right, do you remember what we call the thing here, here, and here?
Yes.
What?
The middle one's the recipe, the last one's the product. And the first one is the equation, all of them are though.
Well, I'm going to call it the ingredients. Okay, because if we're going with recipe, you know, the ingredients, and we also put in there what, you know, what the product is we're making. But this is the recipe, and then this is how much we actually get. So let's look now at bottom of page 277. The chemist forms ammonium sulfate by combining ammonia and sulfuric acid. Okay, so here's what we gotta do. We gotta always, always, always start with what? A balanced equation. All right, so I'm gonna take NH4, 2, SO4. All right, plus,
That's the.
no, that's the product.
That's the product.
By combining NH3
Plus H2SO4.
All right. There we go. Now, without turning the page, stay with me. Ah! You just ripped the page on the camera. We have proof. Ruth, you got ruthless with your book. All right. We should get some. All right. What do we need to do to balance this? Who wants to start? Stephen. Thank you for volunteering. Where would you start?
Oh!
Steve.
I just got excited.
You can start anywhere. Where would you like to start?
Well, let's start by taking the NH4 to making it N2H8.
Like to visualize it, like right above it, so you visualize it.
So you want to just make a note that this is N2H8?
Yeah.
Okay.
Yes.
And then SO4. All right. So we're not changing anything. We're talking about, so I'm looking for prefixes to change. Okay.
Do you have to put a 2 in front of the NH3 so your nitrogen will be balanced?
Or if I put a 2 here,
That works. So an 8.
so now I have 2, and over here I have 2. How many total hydrogens over here?
8 on both sides. Yes, is balanced.
Sulfur 1 and 1, oxygen 4 and 4. Okay, cool. That was easy. All right, so here's the recipe. NH3, H2SO4, and then let's go off the product. Okay. Right, oh my God, there we go. 2, 1, 1, right? So the question is, if she wants to end up making 12.2 moles. So 12.2, now we're using decimal numbers, notice. But we have a calculator, so this isn't so hard. How many moles of each of these do I need? Cross multiply and divide. All right, what do we get for this one, Stephen?
Wait, times what? How many multiplied by?
24.4.
Did you divide by?
Yeah.
Okay. All right, 24.4. And then what would this one be?
12.2.
2.
Yeah, 12.2.
4.2?
Let's do that one with a calculator.
Okay. Now let's turn the page and see. Lo and
So
behold.
much easier than the way
I
it's
don't
written in the
know,
book.
yeah, I don't know why they do it in such a.
They make it really complicated though.
That's what I think. So I'll tell you a true story. This is the method I've been teaching for years, and when Laura, who was in Adasky, took this class with me, and she learned this method, and then she went to nursing school. And she was using this method doing her homework and stuff, and the other kids in class were, wow, where did you learn to do that? It's so amazing. And she's flying through her homework and getting all the answers right. She's smart too, but she told me later that this method really helped her to do well with the math when she was in nursing school.
I will.
All right. Now, today you move ahead. So let's talk about, go to the top page 281.
Experiment, I've done an experiment.
So vinegar and baking soda, you mix the two together and it produces water, carbon dioxide gas, and sodium acetate. Now, if you have, which is what they're talking about here, like way too much of one of the ingredients, okay, then the other one that is less becomes what's called a limiting reactant, or the ones on the left-hand side are the reactants. So the one that gets used up first stops the reaction from happening anymore. So you'll have leftover of one of the reactants, and you've used up the other one in order to produce the product. So the limiting reactant limits the amount of product that can be formed in the chemical equation. At the bottom of page 281 it says, as we begin to do more complex stoichiometry problems, it will be necessary to tell which reactant is the limiting reactant. Once you know that, you can use that quantity to predict the quantity of products formed. In more complex chemical equations, the relationships depend only on the quantity of the limiting reactant. As a result, you can essentially ignore the quantities of the other reactants because the limiting reactant determines how much product can be formed. Okay.
How?
Explain it in English.
So let's walk our way through. Look at the example. I'm going to need on page 282. Let me set up using the equation and then. All right. So Emmeline, the very top of the page there it says what? Magnesium plus 2 HCl.
Oh, yes.
Yield.
Yields magnesium, calcium 2, oh yeah, fluorine, my bad, plus H2.
Okay. So is that
That's all
balanced?
balanced.
I think it's balanced because they told us that there's a 2 there. Okay. So if I put in Mg, HCl, here's the 2 products. MgCl2, put another row in, H2. In this reaction, there are 2 reactants and 2 products. These reactants and products are all relate to one another. If we told you the number of moles of any one substance in the equation, you could use that to calculate the moles of anything else. Okay? Does that make sense? All I need, okay, let's put it in the recipe. 1, 2, 1, 1. All I would need to tell you is that I'm using 3 moles of magnesium, and you could figure out how much hydrochloric acid do I need and how many moles of each of these to be produced, right? Because we can just cross multiply, divide, cross multiply, divide, cross multiply, divide, boom. So all I need is 1 to show the relationships. And I can calculate everything else. Mm-hmm.
So where does the leftover products come in? I mean, the leftover.
Okay, we're getting to that.
limiting reactants.
Yeah.
Like, I wanna know, like, how we solve for that.
Mm-hmm.
I like this, this is easy so far.
Right now.
Well, when you're trying to text, doing it is a lot easier than the text.
So if this is the recipe, and let's say, so these are the products down here, okay? If I told you that we are starting with 2 moles of magnesium, and let's say I have 10 moles available of hydrochloric acid, lots of acid. Once I start, putting these together, first of all, how many moles of this are going to be produced? Cross multiply, divide, 2. Cross multiply, divide, I know we're going to get 2 here. How many moles of hydrochloric acid actually get used?
4.
I'm only gonna use 4. So even though I have 10, only 4 get used, and I have how much left over?
6.
Okay. 6 left over. So really, this is called the limiting
Oh, okay.
reactant, because this is what determines then how many
Okay.
Oh,
are
that makes
produced.
sense.
Because I have way more of this than I needed. Okay? I only used 4 of the 10. So I have leftovers. This was the limit. So they will usually tell you, they might say, you know, we have 4 moles of each to start with. And the limiting reactant is, you know, magnesium. So then you just use that one. You can ignore that actually, because you're just going to have leftovers. Let's see how they use it here in example 8.2.
It's very confusing.
Antacid tablet with an active ingredient which neutralizes excess HCl in your stomach according to the following reaction. If 0.0075, see, we're now using decimal numbers. It's still the same principle. We're still going to plug into this little formula, this table. How many moles of HCl can it neutralize? When it neutralizes that amount of acid, how much CaCl2, H2O, and CO2 will it produce? All right. I'm not going to write the whole formula down because we do have it in the book. But let's write down the information to fill in the chart. Okay. What is the first reactant?
CaCO3.
CaCO3?
CO3.
And then is it HCl?
2 HCl.
Okay. Is it one of the CaCO3?
Yeah.
Okay. And then what does it produce?
3 products.
CaCl2,
Okay.
H2O, and then carbon dioxide, CO2. So
Okay.
this is
So notice, by the way, and this is a good illustration of this. Initially, we only had maybe 3 rows. Last round, we added a 4th row. Because I have 5 things in this recipe, 3 reactants, or 2 reactants, 3 products, I actually need 5 rows for this to work.
Okay.
Okay?
Will they just keep adding it on then? Like, it doesn't matter how
Yeah.
many rows you
Yeah.
have? Okay.
What are the coefficients here?
Just one. All one.
They're all ones?
Yep.
Okay. Now, we're starting with 0.0075 of the CaCO3, and it says how many moles of the HCl will it neutralize? All right? How am I going to solve to find that? Karina?
You take
0.00.
Times 2
times 2,
divided by 1.
0.01.
Okay, everybody see that?
Yes.
You understand that? Okay. Now, why do I always say divide by this one, even though this is just 1? Because in some of the problems, it's not going to be 1. You're going to have like 3 and 2. So you have to remember you cross multiply, divide. All right, now if I want to find this one, I skip this row and I take this number times this number, go back up to this one and divide.
Yeah.
So for this problem, it's times 1 divided by 1. So I'm going to get the same number. Okay? And the same thing happens with all of these, isn't it?
So from now on, we have to refer to the top.
Or if we get
Well,
to it, I think.
Because there wasn't one there.
If you actually want to get an answer.
whichever relation, if they told you that this was the limiting reactant, so they give you this to start with,
Okay.
okay? Then you're gonna take this times this divided by this to get this. This times this divided by this to get this. This times this divided by this to get this,
Okay,
okay?
yes.
So whichever row they give you, that becomes your reference point for all of the
Okay.
ratios.
Okay,
Makes
Okay.
sense. Yeah,
Light bulbs?
yes.
yes.
All right, so you can see the whole problem there, boom. That's what they did.
LED.
You have an LED light bulb.
LED is safer. especially in our brains. Ooh. I guess we don't have many light bulbs, so. Can we do some on the board? Yes, can we do some more?
Yes, 1, 2, 3, 4, 5.
I have a marker in my office.
Go get your marker and get the two that are on the whiteboard, because. Okay. Come on. So I'm gonna turn the video off for now, and we're gonna do the problems from the lesson, one of the homework problems, and then one from the next page, and one from the extra practice, and just get some practice doing this type of thing. All right?